Good morning, everyone. Myself, Professor Chetamala, working as a system professor in Kelly College of Engineering and Technology, Chikkodi. So today in this video, we are going to discuss about that second part of securing IoT. So securing IoT is a part 2 of model number 4. So in the last video, we have discussed about brief history of OT security, and we have seen some of common challenges in OT security. So in this video, we are going to discuss about how IT/OT security practices are going to take place and how they are differ between each other. Then we'll see that what is the formal risk analysis structures. There are two structures that are very popular in the industry, OCTAVE and FAIR. And last one, we'll see that how we are going to adopt new emerging technologies of security over the legacy systems. So in the last class, we discussed about common challenges. So as a recap, we have discussed about the challenges. The first challenge is erosion of network architecture. We have seen that the challenges in developing or designing the network as well as maintenance. Then we have seen certain protocols, ICCP, IEC, and Modbus, where they are having certain challenges like authentication as well as encryption. Then we have seen all about OPC, that is a OLE based operation control that mainly used to control the system in the industry. But the problem in this OPC is it's a vendor dependent, that is a OS dependent, and it is having a RPC protocol is we going to use for communication. So RPC is not strongest one to take the communication. So coming to the next device insecurity, some devices may not be secured nowadays. So we have to think about that trust mechanisms in the devices. Then we have seen certain vendor in clocking. That means that we have to use the vendor specific softwares that are not so much optimized. Then last one is security knowledge. So the OT security people in industry that are not much focused about security about the in OT network. So lack of knowledge is the biggest problem in the OT security. So these are certain challenges that we discussed in the last class. So today we are going to see how IT and OT security practices are going to take place and how they are different between each other. So there are certain parameters. Based on these parameters, we are going to discuss about the differences between IT network and OT network. The first difference is the distance of communication endpoints. So as you know that IT is globally distributed and OT is not globally distributed. It's only about small scale in industry or in a factory, all about single city or multiple cities. But IT is all about the geography located all around the world. So distance between a communication point is so far in IT network and very less in the OT networks. And what are the different types of files we can use in the IT? It may be email files as well as multimedia content. But in OT network, we are going to use some instructions and text data. So we are going to use some instructions for the machines to operate the machines automatically. And text data is used for specification of particular machine working principle. Then the traffic scope is again it's global because it's a geographically large. Then we can consider that traffic is very global. And in this OT network, so as you know that distance between communication points is very near, so that traffic key scope is mainly global. Sorry, local. So it also considers global because sometimes we are going to send the data to the cloud where we can come with a global scope. Along with this, we are using some monitoring and control access areas so that to manage the traffic in the OT network. Then the controlling mechanism. So in ID network, we are having certain application layer protocols that going to control the IT network rather than network layer. But in OT network, it's all about small scale. So point-to-point communications, and along with the publish-subscribe model is going to use for the communication. So the publisher is going to control the thing, and point-to-point is all about that individual machines can take the control of each other. Then clock and synchronization. So sometimes inaccuracy works in the IT network, but as you know that OT is for real time, that inaccuracy doesn't work here. So synchronization should be very correct in the OT network. Then if you want to adopt a new technology, it's very easy in the IT network because we are using so many technologies like virtual machines, virtual network, virtual workspace. So if you come to that OT, we are not so much of focused about that virtual machines. So that all it's all about that when you take the communication, it's all about serial either Ethernet. So only these two are going to use for the adopting the new technologies. So to update the new technologies. Then coming to the point about flexibility and interoperability. So flexibility as well as interoperability is more in the IT network because there are certain standards available in the IT so that take care of both flexibility and interoperability. But in OT networks, these are very less because there is no standard. As we discussed in the previous section about challenges, so main challenge is all about the standardization. So certain protocols we required to develop that should resolve these above said challenges. Then the most critical asset in the IT network is data. So data theft cannot be, data leakage, data theft cannot be taken care. That should be taken care very well in security, IT security. But in a critical asset in the OT security is labor and machine automation. So when something goes wrong with the machines, that maybe losses of life is going to happen. So that the critical asset is labors. Then security focus is all about data theft, data corrupt, data leakage, and data loss. And security focus is mainly on human errors and external attacks. So these are some differences between IT and OT security practices. Then these are the differences between IT network and OT network. Next one is the formal risk analysis structure. So to analyze the risk about in the IT as well as OT network, you should have certain tools and frameworks needed. So in the industry, in the market, in the commercial market, we are having two popular risk assessment framework, OCTAVE and FAIR. So OCTAVE is a operationally critical threat asset and vulnerability evaluation. So that is developed one of the university called Carnegie Mellon University from the Software Engineering Institute. Then one more tool, one more framework that is called factor analysis of information risk. So it's developed from the open group. Now, if you think about the risk management process, how we can going to identify the risk and how we are going to mitigate the risk. So identifying is also a very difficult task, and after identifying, so to resolve that or mitigate the risk, it's also a challenging task. So to do this, we need to have certain steps, certain critical analysis we require. So as a first step, we need to identify the risk. What are the different types of risk are possibly occur in the automation process? So that you need to identify as a first step. Once you identify the different types of risk, you have to go for the analysis of these risks. So you have to prepare certain matrices, certain parameters, and analyze these risks based on these parameters and list out that which risks are high factor, which risks are low factor and low effect. So like that you have to prioritize all these risks. So you assume that if you are having that five risk, you have to think about that which risk is affect the system more. So that you have to give the highest priority to execute and to resolve the risk at the first priority. So once you create the different types of risk as well as prioritize the, now you have to prepare a plan for the execution. So how can I execute, how should I evaluate, how should I identify the problems in the system once you adopt the mitigation process. So mitigation is all about to resolve the risk. So in execution you should always have some monitoring and control mechanism, so to execute that your assessment or analysis. So once you are adopt the any of the risk mitigation method, continuously you have to monitor that risk. So whatever method applied that may not work properly, then it becomes very difficult to manage the particular things in the industry or in the automation. So once you execute, you have to evaluate for that, you have to see the feedback whether risk is properly mitigated or not. So like that you have to take for the monitoring as well as control. If it is completely mitigated, then you can go for the resolving next coming risks. So like that it's one cycle, it can be executed repeatedly until unless you can resolve the all the different types of risks. So Octave. First we'll see about that. What is the features and parameters of Octave and how it's going to mitigate the risk. So as a first step, Octave is multiple iterations. It's going to execute these certain steps in a multiple times until unless it's going to resolve the risk. So why it is famous, or because of its lightweight and less burdensome, and it's also secure. Lightweight means it will not consume much computation power. It may be memory, or it may be CPU, it may be bandwidth. So less burdensome, it's not complex in nature, so that anyone can easily understand, use it and deploy it and can manage it. Then it is secured because it's having certain authentication or an encryption mechanism used in this, so that no one can take the risk analysis data. So these are certain features about the Octave. So next we'll see that how we're going to identify the risk and how we're going to mitigate the risk. There are totally 8 steps in Octave, and it's very important for your examination point of view. So first step is to establish a risk measurement criteria. So first initial step, you need to go for analysis and establish that measurement criteria. So how can I measure the risk? So measure the risk based on that its impact and its value. So impact means how much this risk is going to affect my system. So like that, you can, based on the impact, you can going to measure the risk and list out the different types of criteria to analyze the risk. After you analyzing, identifying certain risk, you should prioritize that which risk should be mitigated first. Like that, you are going to take some reference model and try to evaluate the different types of risk. First step is you just establish the risk measurement criteria. So this is a complete diagram of 8 steps. First step is all about establishing a risk, already seen in the previous slide. So next coming, there are certain profiles, asset profile you have to build. After that, you have to think about that how can I identify the areas of concern, what are different types of threats are possible. Then once I identify the risk, how can I analyze it and mitigate it. So like that, these are 8 step process. So this is a diagram that is taken from the one of the website. Next step. So step number 2, develop the information asset file or profile. So profile is all about a group of information. It may be parameters, it may be working concept, it may be priorities, it may be attributes, who are the roles, different roles available in the particular task. So risk may be depends on events also. Certain events may be leads to the risk, certain events may not be leads to the risk. So you have to identify those things, what are the different types of activities, events going to happen in the particular operation. So you have to develop the certain information asset profile. So that profile is going to help that how we are going to identify the risk. So once you identify the profile, so develop a profile. Next one is identify certain information in the asset profile. So once you need to classify a certain information asset depending upon certain criteria or condition. So these are called as the containers. You have to develop certain containers. So where we can going to report that what are different types of assets are going to fit into the certain containers. So these containers is a group of certain asset profile. So that may be helpful for resolving the risk. So identify areas of concern. So you have to think about that what in which area, whether it's a developing area or it may be production area, it may be any of the machines, packaging area. So where's the certain concern about the risk? Where is the more risk available in the certain automation? So if you think about the factory or automation factory like developing cars, other things, most of the things robots are going to take the certain events or actions or operations in the production. So you have to think about that certain things may go wrong due to certain conditions. So you have to think about that what kind of risks are possible in the automation or what kind of risks are possible in the robots. So like that, you have to think about the areas of concern, in which area the possibilities of risk is going to generate. So once you have the concern, then you have to identify the threat. So what are the different type of threats available? So how can I identify a threat? So it's all about the system is generating so many events. Some events are leads to the threats. Some events may not lead to the threats. So depending upon the different types of events, you have to categorize that whether it may lead to the threats or not. That you have to identify the next step. Now based on this identification, now you have to identify the risk. Certain events leads to the undesirable event, undesirable outcome. So that you think as it's a risk. So you have to list out all these risks and identify that whichever is the highest effect, which is having lowest effect. So list out all the possibilities of risk in the step number 6. And in seventh step, we are going to analyze the listed risks. So quality, you have to say, you have to take certain parameters. So based on these parameters, you have to analyze the risk. The risk, what is the risk mitigation possibility? What is the risk factor? Risk condition. So risk effectiveness. So these things you have to analyze using some parameters. So as a last step, once you analyze the risk, you have to go for the resolving the problem or mitigating the risk. So mitigation, maybe you can take the three different decisions as per the certain standards. So first decision is accept a risk and do nothing. So assume that you found some risk, but you are not going to resolve it. I will not resolve this because this risk is not so much substantial to the threat or vulnerability, so that I will accept the risk but I will do nothing. Then second decision is all about mitigate the risk with whatever control efforts is required. At any condition I need to resolve this risk. That is the second one. Final other alternative decision I can take is defer decision, meaning that it going for the neither accepted or not or mitigated, means that you are in the confusion that whether I am going to accept the risk or not. If it is accepted a risk, I have to mitigate this. So it's in the confusion state about that as a risk assessment. So this is all about the octave. Next one we'll see that factor. So factor analysis of information risk. So that is the meaning is that based on certain factors we are going to analyze the risk. So what are the factors that we are going to study in this module? So it mainly focuses on risk analysis, evaluating the significance of certain parameters as the option. So it's going to support explaining how the analysis was performed and what assumptions were made. So these are the certain categories of risk. So based on these categories, going to design and develop certain patterns or parameters. So based on these parameters, you have to identify that this is a risk. So I have to mitigate this like this. So certain rules are there to resolve the risk. So risk is divided into two parts: loss event frequency and loss magnitude. So what is the frequency of event loss that you have to identify, and what is the magnitude of loss? So magnitude of loss is all about how much loss on this risk. When risk is happen, this much of loss is going to happen. So that's all about the loss magnitude. If you come to the loss event frequency, so you have to think about that whether this came from the threat or vulnerability. Threat and vulnerability are two different things. So vulnerability is all about the something wrong will happen. Threat is a external factor. Vulnerability is a internal or external pattern. So when I go for the threat event frequency, I have to think about that contact frequency and probability of action. So from which event the threat is occurred, from which event, what is the probability of occurring that action in the next coming operations. So like that you have to categorize the things. So come to the vulnerability. So you have to think about that. So what kind of threat capability is, what is the capacity of the threat, and if a threat is happen, what is the resistance power in the operation. So that you have to categorize. So this is all about that loss event frequency. So loss magnitude is again is having two parts: primary loss and secondary loss. Primary loss is a very biggest loss. Secondary loss is a very something is okay, you can manage the that loss. So in the second loss also we are having that event frequency and loss magnitude. So due to this loss, what is the frequency of event is going to happen, how it is going to mitigate it, that you have to think. And next step is what is the secondary magnitude means. So in the first magnitude the loss is very large and second magnitude loss is very less. So like that we can categorize the things. So these are certain factors where I can use the FAIR to avoid the risks. Maybe certain broken models, broken communication, poorly defined scope, focus on the possibilities or probabilities, bad estimation, bad design, poorly defined measurement scales, math on ordinary scales, normalization of risk across the domain. So if these problems are occur, I can use the FAIR to resolve these risks. Now to see the difference between octave and FAIR, so we are having certain parameters like methodology, level, time, strengths. weaknesses. So if you think about the Octave, it's a qualitative approach. So where I'm having to analyze all the critical actions and critical events, and based on that, I have to think about that whether risk is happened or not, and what kind of risk it is. So level is a standard, means it's a standard followed some certain rules and regulations to define the risk. And time consuming to identify the risk is medium time. And what are the strength is it's a free for use. Wider picture means that various organization units are working together to get to improve the Octave strategy. Then it having some different perspective, like it can be used when variety of industries to resolve the risk. And weaknesses, it's very complex and inconsistent with some other models. So there are certain models in the industry. For some models it working properly, some other models it's very inconsistent with the operation. Now coming to the fair is having quantitative. As I told that you have to think about the different types of magnitude, threat, and what is the frequency of threat. So certain parameters you have to calculate and think that what is the probability of the problem in the particular parameters. So based on these parameters you are going to analyze the risk. Then level is specialist, means that what is the difference with standard means? Standard means it taking some standard rules and regulations for the analysis. Specialist means you are applying some special techniques to resolve the and identify the problem. Then it's also same, time consuming is also same here. Then what is the strength is underlying with the logic of thinking. So critical thinking is very important here. If you are having critical thinking power, then you can go for this pair, otherwise it's not working properly. Then dependable results, you can depend the results because of this it happens like this. So that results what you are getting, that is very dependable. So next one is weaknesses. Again it's a complexity, not applicable without metric data. If you are not able to generate some parameters or metrics, this model is not used. And again it's inconsistent with the some other models. So this is all about the difference between Octave and FAIR. And this is the last topic where we can apply the emerging technologies over the legacy system. So how can I adopt new technology to the outdated systems? For example, if I want to apply new security algorithm for the my old machines, how can I do it? Okay. And second part is all about monitoring. How can I monitor the certain industry equipment with a certain parameters? So there are certain steps to adopt the new technology, security technology in the OT. So we have to introduce some modern security techniques over the legacy system. It should be begin with a very modest and non-intrusive steps. I mean, it should be in a secured way. I have to do with the implementation of new technology in the old models. So first one I have to do about the analysis. First step is analysis and secure network design. So before going to adopt new technology, I have to design my security network security, and analyze that what type of network it is. So meaning that security is all about only when you are coming to the taking place of communication. Then what are the factors involved in the communication that you have to analyze and design on secure network, so that it should not should be very robust and efficiently built in the next coming operations. The communication function should be segmented into zones. So there are certain communication functions, there are different types of functions available. So these functions can be categorized based on the zones. You have to divide the complete network into the smallest zones, so where it's easy for the analysis. So communication crossing the boundaries of these zones should be secured and controlled through the concept of context. What is meaning is, whenever I go to take the communication between one zone to another zone, these communications should be very secured and controlled through the certain transmission functions. So that is the meaning of that, where the boundaries of the zones. Then professional discover of the state of the network and all communication channels. You have to discover the network status, as well as you have to see that and analyze that all the communication channels available in the network. This is all about that analyzing and designing the network. Next one is network discovery. So you have to analyze the network, you have to discover the certain patterns in the network. So that's all about the network discovery. So whether it is a safety, security, what is the operation state, that you have to discover, and we have to manually you have to go for each and every location of the network like switches, routers, and try to identify that what is the problem in that one. Then how can I upgrade this technology to that network equipments, and must include the search of wireless access points, and you have to go for the particular wireless access points and see that whether it's possible to adopt the new technology or not. Some outdated wireless access point doesn't work with the new protocols, so you have to do check that interoperability parameter also, and tracing the network flow. So you have to, once you discover all things, you have to inject the data into the network and see that how it is flowed in the network. Next one is connectivity state of all physical connections. So how many connections, physical connections are exist in the network? You have to check the connectivity of all these things. Then once you are done with the discovery, next step is you have to check that whether what is the analysis of connectivity. So starting with the cells and zone level, it is important to see that what is the aggregation, what is the certain parameters in the certain functions in the aggregation point, because when you transfer data from that lower zone to upper level, so there are certain aggregation points are there. These aggregation points going to collect the data and pass to the next level. So like that aggregation point is very important, so you have to think about that and check about that whether aggregation function is secured or not, sorry, aggregation points are secured or not. And recommended to find the data paths, what is the different paths available for the transmission of the data, and check the physical port activities. There will be around 1,000 ports are possible to have the in the network, especially in the OT. So you have to check that activities in the all the ports, whether it's a misbehaving some activities occurs, then it leads to the problem to the network. Then once you've done the analysis and try to adopt the new security mechanism, if I take the example of VPN, SSL, you can use the for secure purpose. So VPN is a virtual private network, SSL is secure socket layer. Using these two, you can secure the your network without harming anybody from the outside. So if it is able to do that MAC based access control, that's also fine, but MAC based access doesn't work with one scalability issue, because when there is a network is very large, this doesn't work properly. So that you have to think about the feasibility of MAC access control security. Otherwise you can go for the VPN and SSL. So these are the certain 4 steps uh, strategy that mainly used for the securing the network with the new technology. Then once you adopt the new technology, you have to monitor that for any analysis purpose. There are certain applications of monitoring are like that. First one is troubleshoot. If something goes wrong with the machines, you can the data whatever collected, maybe log files, maybe events, maybe certain values that may helpful for the troubleshooting. And fault tolerance means if something is going on with one machine, other machine will distribute the data and work should be done with the in complete short time. Then also it is used for the prediction. You can predict that whether in the future if there is certain risks are possible or not. If it is you predict that one risk is available in the next coming days, you can resolve the that problem by applying new technology, new resources to that particular state of the network. So these are the certain things about that how you can improve the network security by adapting new emerging technology in the network. So this is all about the model number 4. So in the next session, we're going to discuss about the model number 5. Thank you.